Hello, this is the luckiest maths teacher in the world. Thank you so much for tuning into this video. By the end of it, you should be able to write the domain and range of given functions. So here we have a function, just like we had in a previous video. It's a function because each member in the first set is mapped to only one member in the second set. There are no members of this first set that are mapped to more than one in the second set here. So the first set is the domain and the second set the range. So as I said, this map here is a function. So if we're going to write its domain, all we do is write all of the values in the first set that have been mapped. So that's all of the numbers you see there, 1 to 5. So we write the domain like this. Note we have to have these squiggly brackets because mathematically they indicate a set. This is a set of values that are mapped. So we do so similarly for the range, but we don't include the one that doesn't have a pair. So 7, 9, 10, and 11 are in the range, but we don't include the number 8 because there's no number from the first set that's mapped to it. So that's how we write in the domain and range for this function. Let's look at an example where we're given a graph. So let's look at this function here. This is a function too, a mapping from x to y. So the domain is all the x values it can take and the range all the y values. So when figuring out the domain, we need to look at these circles. So hopefully you remember from when you graphed inequalities on a number line, a closed circle means you include that value, and an open circle means you don't include that value. So to write the domain for this, we'll once again need squiggly brackets because this is a set. So we write x because this is the set of x values, and we use a colon. That means such that. So this is the set of all values of x such that x is between -3 and 5. So we write between -3 and 5 like this. This says that x is between -3 and 5. We put the little dash there because we include 5, but we don't include 3. So if I want to write the range, I do something very similar. Once again, I need squiggly brackets. Now we're looking at y values. So this is the set of y values such that y is between 0 and 4. Y includes those values. We include 0. Y is 0 down here, that's the lowest value of y, and the highest value of y is 4. And there we're done. We've written the domain and range for this function. Now we're going to write the domain and range when we're just given the equation. Let's start by looking at y equals 2x, which we know from a previous video is a function. So when we're looking at the domain, we're saying what values of x can I substitute into this expression here? Well, you can substitute any value you like. You can double any number you want. So I write it like this. X such that x is a real number. So this here is the shorthand way of saying x can take any value. Now y can take any value as well, because if you substitute literally any value for y, you'll be able to solve this equation and find what x is. So we're going to write something similar for the range. So once again, this says y can take any value. So let's now look at the function y equals x squared plus 1. So again, the domain is saying what values of x can I substitute into this formula? Well, you can again substitute any value for x. You can take literally any number you want, square it, and then add 1. So same as before, x can be any real number, but y is going to be different this time. So the reason for that is x squared here must always be greater than or equal to 0. Whenever you square a number, it's never negative. So x squared plus 1 must be greater than or equal to 1. But this here is just y, so I can rub it out and replace it with y. And that's how I find the range. So here, the range is y such that y is greater than or equal to 1. Once again, we need the curly brackets because it is a set. So I'll just show you quickly what the graph of this would look like. So hopefully you remember, the graph of y equals x squared plus 1 looks like this. There are no y values on the graph less than 1. So that's why the range is y such that y is greater than or equal to 1. All right, let's look at a few more examples. So I'm going to get rid of this. Please pause and copy down if you need. Let's look at this equation here, y equals 2 over x minus 3. So we'll start with the domain. So once again, we need the squiggly brackets. We're talking about x. So this one's different because we're dividing by an x. You can square any number, you can double any number, but you can't divide by 0. So the bottom of this cannot equal 0. So that means x cannot equal 3. It can take any other value. You can divide by any number not equal to 0. But x cannot equal 3 because then we'd have 2 divided by 0 and you can't divide by 0. So looking at the range now, so we can't divide 2 by a number to get 0. If the numerator of a fraction is not 0, then the whole fraction cannot equal 0. So we have y cannot equal 0. So I'll just quickly draw the graph again. So hopefully you remember y equals 2 over x minus 3 is a hyperbola, and this is what its graph looks like. It has an asymptote at x equals 3. So x cannot equal 3, it gets closer and closer to, but never actually hits x equals 3. Similarly, this will never hit the x-axis because y can never equal 0. So I'm going to rub that out again and do the next example. So looking at this example now, if we want to find the domain of y equals square root of x plus 1, we think of what values of x can I substitute into this formula. Remember, you cannot square root a negative, so I must have that x plus 1 is greater than or equal to 0. And that implies that x is greater than or equal to minus 1. You can't substitute a number like minus 2 in here, because then you'd be square rooting minus 1. So then we write the domain like this. Remember, we need the squiggly brackets because it's a set of values, and we need to write x because we're talking about x values. So now we look to the range. Unfortunately, it's a bit ambiguous. So when we're talking square root of something, it's understood we mean just the positive square root. So the range would be y such that y is greater than or equal to 0. For this last example, we have y equals x cubed, but we're told x is between and including 2 and 6, so we're restricting the domain. So to write the domain, we again need our squiggly brackets. Simply need to write in this information. So x such that x is between and including 2 and 6. So we include the values of 2 and 6 because of this less than or equal to sign. Okay, for the range, so we'll need the squiggly brackets again, y values. So if x is 2, the minimum value of x, y would be 8. The maximum value of y would be 216. And y could take any value between those two, because if you cube root any number between 8 and 216, you'll get the x value between and including 2 and 6. All right, we're done. Thank you so much for watching. This has been the luckiest maths teacher in the world. Have a great day.